Alright, so we looked at capacitors as statics. Well, capacitors are put in circuits. Now, you should remember this equation right here. C equals Q over V. It's a lot like Ohm's law, but for capacitors. You know, Q equals CV. That's another way I just rearranged it. Okay. C takes the place of resistors with a few changes. Okay, so let's keep this in mind. Q equals CV. The charge, Q, is very much like current, I. Okay? Current is charge divided by time, number of charge. Okay, so you can think of those as being similar. V varies, okay, on a resistor, but it adds up to the total. Series circuit, right? Charge the same. Potential difference adds up to the total. That's a heck of a lot like a regular series circuit. In a series circuit, current is the same, and V adds up. Well, V still adds up, but now charge is the same. Okay? Now, in your reference table, you are given this. And this is how you find the total current in a series circuit, which looks a lot like resistance in a parallel circuit. So they kind of flip how they're set up. Okay? So if you want the total capacitance in a series circuit, when the capacitors are set up in series, one after another, then you would add up their inverses and take that inverse. Now if you're dealing in parallel circuits, the potential difference across each resistor is the same. V1 equals V2. Same as with Ohm's law in a parallel circuit, right? And each current adds up to the total current. Or in this case, each charge adds up to the total charge. Oh, this one has 3, so it would be 3. Okay? And capacitance is calculated by adding them together. So the big thing that changes is you have Q instead of I, and CP and CS are switched from RP and RS, right? So just the way the circuits are set up. Alright, the rest is solved just like problems we use with resistors, except for we use this instead of this. Let's look at an example. So, we have C equals Q over V. Let's keep that in mind. Now, these are capacitors in parallel. So CP equals C1 plus C2 plus C3 plus C4. And we want to determine the capacitance of the single capacitor that is equivalent to the parallel combination shown above. So we basically want CP. CP equals, let's see, 3 microfarads plus 6 microfarads plus 12 microfarads plus 24 microfarads. So 3 plus 6 is 9, plus 12 is 21, plus 24, let me see, 21 plus 24 is 45, yeah. So capacitance is 45 microfarads, or 45 times 10 to the negative 6 farads. Now the total charge contained in the configuration. So C equals Q over V. So total charge, we need total capacitance and total voltage, which we know from the picture. So 45 times 10 to the negative 6th equals Q divided by 18. So Q equals 81 times, I believe, 10 to the 7th or 8th? 8 coulombs. Bam! Not too bad, right? Just like Ohm's law, except for capacitors. Alright, that's all for the lesson. Good luck on your homework.